Let's look at a problem that can be solved by using sets. 300 students are enrolled in a math course or a history course. 210 of them are taking the history course, and 135 are taking the math course. How many are taking both the math course and the history course? Perhaps the easiest way to see how to solve this problem is by using a Venn diagram. This diagram shows two sets of students as circles, with a circle on the left containing the students taking the math course, and the circle on the right containing the students taking the history course. Notice that the two circles overlap. This overlapping part, colored blue, represents the students who are taking both the math course and the history course. It's called the intersection of the two sets. Our problem is to determine how many students are in this overlapping part. To answer this problem and other problems, let's review a few concepts of sets. Suppose we have two sets, A and B. Then, as we discuss in our review of set concepts, we can create new sets by taking the union, intersection, and difference of A and B. The union is the set of all elements that are in A or in B or in both. The intersection is the set of elements that are in both A and B. And the difference, A minus B, is the set of elements in A that are not in B. Now, to solve the problem above, we need to know how many elements are in various sets. The number of elements in a set is called the cardinality of the set. To get the cardinalities of each of these sets, we use these formulas. The cardinality of A union B equals the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. The cardinality of A intersect B equals the cardinality of A plus the cardinality of B minus the cardinality of A union B. The cardinality of A minus B equals the cardinality of A minus the cardinality of A intersect B. Now let's solve the problem. The total number of students is 300, which means that the union of the two sets has 300 students in it. That is, the cardinality of math course union history course equals 300. Now the question asks us how many students are taking both courses. That is, how many students are in the intersection of the sets. In other words, the cardinality of math course intersect history course is what? Here's the formula for the intersection of these two sets. The cardinality of math course intersect history course equals the cardinality of math course plus the cardinality of history course minus the cardinality of math course union history course. We can calculate the desired cardinality by adding together the number of students who are individually taking each of the two courses, 135 and 210, and subtracting the total number of students, 300. Here you see that 135 students are taking math and 210 are taking history. Subtracting the total number of students, 300, we get 135 plus 210 minus 300 equals 45. So the number of students taking both courses is 45. Here's another example. How many students are taking the math course but not the history course? In this case, we want the cardinality of the set difference, math course minus history course, as shown in this diagram. We can find this total by using this formula. The cardinality of math course minus history course equals the cardinality of math course minus the cardinality of math course intersect history course, which is equal to 135 minus 45, and that's equal to 90. So 90 students are taking the math course, but not the history course.